fight on video. Yeah, I guess they did. I mean, ankles used to be like the old tits. Like, you used to show ankles. Girls used to show ankles instead of showing tits. It's kind of crazy. Alright, so all this stuff can be constant now. So direction is equal to k times 2 minus 1, k mod 2 times 2 minus 1. And then the next value is the k plus direction. Alright, so that should do the first step. Well, I can tell you one thing where there are no women around, men work harder. I don't know, because there's like a bunch of men that'll work to please women. Or provide for their families, which include women. Alright, so yeah, you can see in the step 0 here. Oh, it's actually wrong. It's supposed to split the array into into length 2 subarrays like that, but it's actually splitting them like this. I think I have to swap this direction. Okay, that array was already sorted. That array is already sorted. There we go, that one. So here you can see the 9524 down here gets swapped 2495. So that's the first step, is it splits the array into smaller sorted, basically the smallest sorted arrays you can, which is 2. Sets of 2. So I actually need to think if I guess if it's not aligned or divisible by 2, then I can just like skip this last element and just consider it sorted and treat it. But you know what, I'll do that afterwards. Working on non-aligned arrays would be harder. So then down here is actually going to be the main part of the merge sort, the merging. So now we need to merge these two into these 2 length arrays into a 4 length array on each side, and then finally the last step will merge those 4 length arrays into a 8 length, the actual length of the array, and we'll have our sorted array, and it'll be done in half the steps of a bubble sort and with less operations. So this code here merges 2 lists together of a size of 4. So I guess I need to use that same code I had there. It was like pow2 I. So here the length will start at 2, which is what it is. And now this is going to be pretty easy actually to implement in JavaScript here, but it's probably going to be a lot harder in GLSL to do this optimally. Welcome back. So this A1, A2 stores the index of the array. What I meant is men get horny easily. I mean, women do too, they just don't show it as well. Or they aren't as obvious, I guess. I think I either need to store the base index here or the end index to compare this against. Yeah. Being horny makes you not think right, you know? I think it just makes you think differently. Whether or not it's right is subjective. So I'm just going to loop through the output. And you know what? I don't even need to store the last value. I don't know why I was storing that there. But yeah, this 4 I wrote here is actually supposed to be this half variable. Isn't it crazy we have videos of veterans of the Rebellion War? Yeah. It's just crazy that we have war. Well, war is crazy. Okay, so this A1 is going to be... Oh, okay, so I have to divide this. This is going to be the hard part. So A dot length divided by size, I guess. Being a pacifist requires everyone to also be, yeah. It also requires there to be no limit on resources or food or hunger. I don't like the word peace, I like the word working together. Mutual benefit. Man, I'm sitting in my room right now with no clothes on and a fan blowing on me, and I'm just sitting at the computer not moving and I'm fucking sweating. Jesus Christ. Yeah, you know what also makes you not think right? Really hot weather. I slept in the car the other day, I had water all over my face. Jesus. I can't actually remember the last time I slept in the car just because of how hot it gets. I used to sleep in the car. Being angry. Just distractions then. Well, at least you were sweating. Okay, that's bad that you couldn't breathe, but if you're sweating, it means you're not going to die from heat stroke. Because it's going to evaporate. Alright, so I'm not sure if this part, if I'm supposed to do size 2. I think it's supposed to be size. By work, do you mean like exercise work or like paperwork sweating? Or like tense business meeting sweating? Oh, mechanics, yeah, that makes sense. So right here I loop through the whole array and I just increment these, but I need to check whether or not they meet the limit, which for this one will be the beginning of A2. So I'll just store the limit, which for this one is A2. For A2, the limit is J plus, actually it's A2 plus size 2. Those plastic things make you sweat. Gloves, yeah. Oh yeah, they have yeah, it depends what gloves too. In surgical gloves, they specifically have that special powder to stop your hands from sweating. And I hate it afterwards because you always take the gloves off and you have your hands covered in the powder. Fingertips shrivel up? Yeah, like prunes. So maybe I should actually limit these array accesses. This is going bottom to top, so it'll start with lower numbers first. You're gonna go see a football match? Have fun. Don't sweat too much. Don't get heat stroke. Yeah, I can't help with your shader. Are you still posting it in the Discord, or if you post it in Discord or wherever, I'll eventually see it. I'm lurking in your Discord too. Is it the problem with the pathfinding? Yeah, pathfinding problem. All right, that is a difficult problem. Screw optimizing this. It's a pretty hard problem. Check if they emit power, then find the shortest path to the wire. Yeah. I would try and look at creating some sort of progressive distance function or something that calculates the distance. Like basically the wire emits like a distance field in a different buffer, and then you just look up on that buffer where the distance is, and then it would basically take, like, if it propagated like one cell per frame, it would take like 30 frames for the distance to reach 30 cells, so there would be like a little bit of delay in the update, but it probably won't be noticeable. Yeah, so screw optimizing this at this point. I'm just going to do this. Oh man, I'm so obsessive. I need to do the optimizations. The thing also has to be done for every wire. Yeah, I don't know. I'll have to look at the ways that you have the wires overlapping or however you're sorting them. Alright, how would I optimize sampling these values? I think I might want to have some flag that's like... I guess I have to check if it's above a certain value, so if done 1, done 2. Alright, see you later, said who. Thanks for stopping by. Have fun at that football game. So then I do the same thing here, that's if not done 1, and V1 is smaller than V2, or done 2. Otherwise, the value is this. So SV is going to be the set value for this position, which I guess I'm going to just store an index and then I can just increase it each time. So I do output array index plus plus equals the set value. Then right here, SV equals V1, A1 plus plus, if A1 bigger than A1L, then done 1 is true. I can actually just assign this and do done 1 equals that, and then here I can do A2 plus plus and done 2 equals A2 bigger than equal to A2L. Alright. That should be an optimized version of the merge sort. Or at least that part optimized array samples. I actually didn't upgrade this. So this is supposed to be if not done, then assign V1 to the next sample, and if not done 2, assign V2 to the next sample. Okay, let's see. Alright, so there's the first step. Splits it into 2. You know what, let's try. Oh, I didn't add a check that checks whether or not this is done. So if the size is bigger than the length, or I actually think if, so the final size is, yeah, so if the size is bigger than or equal to length, or actually size 2, length divided by 2, I think it is. We'll try this. Return false. So this basically runs until this returns false. test it out. Does the first sort, and then it actually fails to do the second sort, and it backs out. Okay, so what is happening there? Oh, maybe because I'm doing I again instead of J. So what this is supposed to be doing from this step here is it's supposed to be combining these two into one larger sorted array. It's not doing that. So let me think. As 1, this starts out as 2. So for 8, the maximum one is going to be divided by 4, I think. Maybe this is supposed to be I plus 1. Let's try this without exiting out of the loop. 45, 63, 72. So yeah, there we go. It is supposed to be I plus 1. So now that is divided by 4, I believe. Yeah, so that is with size equals 4. So the next one, size equals 8, is the last one. So if size is bigger than the length, is what our check is going to be. Boom, we've got sorting. Okay, now let's increase this to a 32 length array. 4, 7, 11, 13, 20. Awesome. We have implemented efficient merge sorting in JavaScript. Hell yeah. All right. That's good progress. The next step is going to be converting this to GLSL, which is the actual hard part. So I will be right back. I got to check on my cat again.
From the plains that sleep below to the canyons open wide, hear the song of gentle mourning for the lost and lonesome bride.
Alright, it all of a sudden started thundering and pouring rain outside. So I am going to, before the power cuts out, I'm going to try and speed this up because I really want to get this I really need to get this merge sorting in GLSL done so I can use it for another project. So I'm gonna put on some actually good music. Ah, this gold noise post is really cool. Alright, so I already had merge, sort, subdivide, divide and conquer. Alright, this music is definitely going to pump me up enough to do this, so let's get started. Alright, so obviously this is a much bigger sorting job. I was basically doing the same code as here, this first part, so I'm going to refactor it now. It initializes with noise. So what I'm going to do is I'm going to check if iframe is 1. Divide into length 2 sorted arrays. So that's the same part right here. The shader loop does this. So basically all we need to do is do this part of calculating the direction. So this is like times -2 plus 1. There we go. So then we check if dir bigger than 0. Oh, I forgot a parentheses there. Alright, so if direction bigger than 0, if b is bigger than n, then we set b to n. If n bigger than b, b equals n. Okay. So I'm just going to output to O the V here. So this first frame just divides into length 2 arrays. And we're going to erase all that old code. Alright, now to test this, I'm just going to output current value. So what this should do... Okay, I think something's wrong because it shouldn't have this huge divider with all the white on one side and gray on another. iframe equals 1, else. Let's see, what am I doing here? You know what? That looks correct. I'm not going to argue with it. That's the algorithm, so it must be right. Oh, I did times 1 instead of times 2. That explains it. Wait, does it? Huh. Oh, I'm doing u.x plus direction here without adding u.y. There we go. So you can't really see, but it does a slight shift each pixel. So now this next part is the part that's going to be a lot slower on the GPU. And that is threading the two lists together and merging them. So the reason why this is so slow, because at like the middle point of the array, so at the beginning of the array it's simple. The beginning is either going to be at one of the two, you're basically merging two lists. So on the GPU you can't do it element by element. I need to compute what this element's result is in this fragment program without doing it step by step. So I basically need to loop through all of the elements until I find this element, which is very slow. So one of the optimizations I'm going to try to do is starting the search halfway through, or like basically if it's starting at the end, you can almost be sure that it's going to find the answer at the end, and if it's starting at the beginning, it's going to find the answer at the beginning. But when it's middle way through, it could either find the answer at the end of one of the lists or at the beginning of the second list. So this is going to be the hard part. I guess I'll just do it unoptimized first. Recursively merge lists until length is iResolution.x. And this is the other hard part here, is if it's not 512 width, it probably won't work. So that's going to be, I'll deal with that afterwards. So I'm just going to copy this same section of code here. It starts with calculating the size current step. You can see right here, pow to I plus 1. I'm not sure if I want to do this in an integer or float, because
the year 3030.
Yeah, not going to listen to this. It's not the right time for Deltron 3030. Yeah, I guess I'll just do it with this. So pow to I is iframe. Let's float iframe like that. And then I'm going to check if size bigger than iResolution.x. It's done. And then at this point, we're just going to return So at this point, it'll be done sorting, and we're just going to return the constant value without doing any computations. You know what, I'm going to stop going between these pages, I'm just going to copy it into comments here. Alright. Size 2. Length. Alright, I don't need this index. And yeah, so instead of looping through like this, I'm actually going to be doing it differently here because it's on the GPU. So, So S length is going to be search length. Equal to I resolution divided by size. So this is actually the difficult part. I'm not really sure how I want to do this. I mean, I guess I should search through the one array first. Oh man, I'm not sure how to do this. I guess S length is actually going to be the length of the current index, the maximum search that it has to do. So that's u.x. If it's at 0, it should have to do 0 searching to find the value. Alright, so this is probably +1. I guess I'm going to cache the values. So what do I do here? I initialize with the value samples? Yeah, okay. Texel. Oh yeah, so this is going to be the difficult part. So right here I have to do u.x plus So this is the part where I actually think I use size 2. So then it floors to size, and then the batch size is size, but the sublist size is size 2. So it starts the one index search at size 2. Alright, so I actually need a base X. Oops. so I'm going to create a variable called vx. It's going to be floor u.x divided by size. Now that's the base. I actually think I should do multiplied by size afterwards. Then the first value is at bx u.y, and value 2 is at bx plus size 2. Or actually, I guess I should have bx2, which is bx plus size 2. So now I need that same bool, I think, that's done 1 and done 2. And I actually should also have the integer values, I think, for the maximum bx and bx2. So bxl is bx2, bx2 2l is bx2 plus size 2. Done 1, done 2. Maybe I should actually, I think it's actually easier to check if something's true. So I'm going to change it from done to on. Alright, so then we're going to do the same code as here. Or nearly the same. If not done, or not, if on 1, and v1 smaller than v2, or not on 2, oh yeah, so this is the hard part. Instead of just finding the next value, I need to loop through the whole thing. Huh. How loud's this music? I guess it's not too bad for the stream. Okay. I think I just repeat this, actually. Looking at this, I think I just do ex plus plus. I actually think this isn't plus 1 here. I just do this plus 1, and then at the end here, I just assign the output to the bigger one of this value 1 or value 2. So I basically do the thing that's in the loop in here. Okay, actually, so just write this, exx plus plus, if on 1 equals bx smaller than bxl, v1 equals texel fetch. Alright, else bx2 plus plus, and then the same thing here but with bx2, if on 2, x2 is smaller than bx2l, v2, and bx2. Alright, and then I believe here I do the exact same thing. but instead of incrementing anything, I do O equals V1. Or here, I do O equals V2. Alright, let's see how this works. It compiles, that's a good first step. Holy shit, it sorts. Oh my god, it actually sorted. Whoa. Did I just program something in the first try? Okay, let's try this with a non-hashed base algorithm. So this is supposed to sort from higher values on the right, lower values on the left. It looks like it's working perfectly fine. Just to make sure, let's initialize it with lower values on the right and higher values on the left. So to do that, it's just u.x divided by iresolution.x, and then 1 minus that. So now it initializes with the opposite. Okay, no, there's an error with it. You can actually see it doesn't preserve values. In the process of switching the dark to the light and the light to the dark, it loses the values. Okay. So there is something wrong with it. That's good to know. Now let's figure out what's wrong with it. Maybe this is supposed to be +1. I don't know. Maybe this is supposed to be ×2. Oh wait, this isn't supposed to be x. This is supposed to be x minus base x. I'm an idiot. Okay, so int s length equals int u.x minus base x. So this is like modulo x by size. Holy shit, it works. Oh my god, it sorts the whole thing. And it only drops to like 30 frames per second. Okay, and this can be optimized. Like I said, this is looping through the whole thing. But you can actually optimize this because, for example, if you're at the middle of the array, you know that... Oh, wait. Oh, this is actually really difficult. If you're at the end of one array, you know it's going to be at the end of one of the other arrays, or at least halfway through. So there are optimizations to be made here, but this should be pretty optimal. Looking at this with the hash too will probably look pretty nice. That's really nice. Awesome. Alright, so that was my goal for this, to get this merge sort done. Now I'm wondering, do I want to spend the time optimizing this? I guess I could look at, I'm thinking I can at least cut the operations in half here. Oh, okay, I don't need the pump up music anymore. Man, when I'm trying to concentrate on something, it helps me so much to just turn up the music. Alright. So I'm thinking I can at least cut the operations here in half by just starting this iterator later. Basically just skipping this I ahead to like halfway. If it's like, if s length is like, yeah, so if s length is like getting to really high point, I think I could do like s length divided by 2 here and somehow start this ahead. But that's stuff to test. I'll be right back. Okay, so we got thunderstorms, and it's like 2:30 in the afternoon, but it looks like there's a goddamn sunset at 2:30 in the afternoon with the way the clouds are. It's actually stupid. I don't know what Mother Nature's doing these days. Okay, let's try and optimize this. So starting this at S length 2, or actually, because I don't actually use this I for anything, I can just divide S length by 2. But before I do that, I think I need to skip it here, so I do... Oh, this is going to be the really hard part. Or the part that requires thinking, actual thinking. I'm already happy that I got this working, because this is already way faster. I have another sorting for GLSL that's like a just brute force sort, and this same sort would have taken like 5 seconds at least. Actually like 10 seconds, or maybe like 8 seconds with that system. So this doing it in half a second is actually beautiful. Actually less than half a second. So cool how you can see it happening as well. Anyways, so the logic behind this optimization is the beginning of this is already optimized because it only loops through. If it's at like the 5th element here, it's only going to loop through 5 elements to find it because it knows it only has to loop through 5. But if it's at the end, and with this, the end is like 512, which is already pretty big, and I want this to scale up to support thousands. So when this gets to the end and this is equal to like 256, it's going to be looping through a whole bunch here. But the logic is because you know the shortest list is 250, or because you know the lists are 256 in length at that point, or they're half of this size, size 2 right here, you can essentially skip ahead. So actually, if I do it, it's probably easier if I go into this JavaScript test. So right here, it splits it into the 2x2 and it merges them to the 4. Merges them into sets of 4. So what I would do here, when I'm merging the 4 into the whole, so for example, when it's finding this element, it basically already knows it's going to be at the 0 index of either here or here. That's why there's 0 iterations here. On this second one, the index could either be here or it could be in one of these. So as you see, as it gets closer to the middle, it has to search farther into the list to find the possible result. And as it gets to the end, it begins looping, it begins ramping up a whole bunch. Once you're here, it begins searching through all the way from the beginning just to find these end elements. When you know for a fact, after this halfway point, at this 46, it's going to at least be starting at like the halfway point right here. So that's the optimization that I'm trying to create is that as it goes through the list, it also starts the search later in the list. So I need to do this so that it doesn't skip any elements. So the beginning here, I need to think about this. So if there's 46 here, it's at element 1 of the second array, which basically means that So this is the other difficult part, is you don't know which one of these two arrays comes before or after the other. That's why you need to search through both of them and merge them. But basically, in a worst case scenario, one of these lists will have a whole worst case scenario is one of these lists has all of the lower elements. So once it reaches the halfway point, it only starts this next list here. So basically, after the halfway point, we can begin knowing for certain that it's not going to be one of the first elements. So already as an optimization, after the halfway point, we can actually begin ramping down the search. Or at least skipping part of it. So the exact operation for this would be size divided by 2, because it's at the halfway point right here. Actually, I think it would be minus size divided by 2. Alright, so you can actually kind of see here the f frames per second is like 8. 18, 20. I'm going to see if this actually goes up when I do this optimization. So let me see if s length bigger than float size 2. Actually, integer version of size 2. Alright, so I can increment both arrays by this at this point. So let me actually think about how this works. At the final element here, we can be sure it'll actually be one of the final elements of either of these arrays. So that's a huge optimization too, because it means we don't need to search through this whole thing. We can skip. So I don't know if this would be, I don't know, let's just try it. Skip equals, you know what, I'm going to do this all as floats first. And maybe not. Float skip equals float. What is it? So I actually think what's going to happen is the search length is going to go up the most at the middle, and then after the middle, the search length begins going down again because it doesn't need to search for as many. Like I said, when you're at the beginning, you know it's going to be one of the elements at the beginning, and when it's at the end, you know it's going to be one of these elements at the end. It's just at the middle where you need to search through. Alright, so how am I going to have it scale up and down this search length? So I already said at the halfway point it begins going down, so that's the half I size 2 right here. Alright, so you know what, let's just start with the S length minus equals I size 2. Actually, that doesn't work. I do need to calculate the number of skipped first. So I guess if it goes up and then it goes down, it's just a triangle wave, right? So I think I'll just start with that, which is, oh, you know what? This should be a float. This should be a float. I'll be right back.